All right. So this is a bonus video. No one has to do this. This is just getting you ready for grade 10 a little bit. So what I'm going to do is I'm going to take probably 15-20 minutes to go through a whole bunch of concepts, actually an entire unit in kind of condensed, accelerated way, and hopefully it helps you figure out what we're working on. So the very first thing you have to realize is that anytime we're dealing with lines, linear equations, they are graphs. So anytime we have a graph, we have data, we have points, and we also have an equation. So hopefully that's not new information for you. This might be those. So there's two main ways to write the equation of any line graph. So the big thing while we're going through is anytime you see x and y, remember these are just coordinates. So whenever we have a coordinate that x and y meet, that will tell you points along the line. Let's go. So this one here is called standard form. So we have ax plus by equals c. Just like in algebra, we have forms. This form allows us to determine the x and y intercepts of a line really quickly. So if I have these numbers in here, if a and b are numbers, I can make x 0. If I make x 0, what it does, it takes that away, and now I'm looking for, when x is 0, that's going to be the x-intercept. When I make y 0, well, I just have to divide c by a, and that's going to tell me what x is when y is 0. Now remember, when y is 0, that is my y-intercept. So that's the benefit of standard form. We can quickly plot 2 points and then draw our line. Talk more about that in a bit. The other form is called slope-intercept. This is the one we work a lot with in grade 7 and grade 8 and grade 9. We're not going to get to it a lot this year though. So this one is y equals mx plus b. So this tells us the slope, and it also gives us the y-intercept. So m is going to tell us how steep the line is. So that's calculated by the rise over the run. So how much a line goes up. So if I have a line like this, it goes up 1, over 1, up 1, over 1. That's going to be a slope of 1. And b is the y-intercept. So our b here is going to be the value of y when x is 0. So again, if we make x 0, this whole thing now is irrelevant because anything times 0 is 0. So that's what the b is. So those are the two forms. You're going to have to become comfortable moving between the two. So in standard form, the only rule is that the coefficient on the x has to be positive. So sometimes you have to multiply each term by negative to get there. So here we go. Let's switch it around. So here's my slope-intercept. I can tell because I have y equals. We want to get it to this. We talked a lot in algebra about how to move things around. The first trick is that if x is already positive, don't move it around, because if I change this to the other side, I've got a negative 4. So we're going to try and make this easy on ourselves. Right? So here I'm going to move things to the side of the x. So I'm going to get rid of this first, my positive 2. Long form is minus 2 on this side and minus 2. These cancel out. I get y minus 2 equals 4x. We're closer. I need to move this y. So the other way to do it, remember that's a positive. I can change sides of the equal sign. I change the sign. Now once I have these on the opposite sides of the equal sign, I can rewrite it in my standard form. So we're just moving things algebraically. So I get 4x minus y equals negative 2. Does it make a criteria? I've got coefficients, an x and a y, and a c. Here I've got coefficient of 4, coefficient of negative 1, and I have my constant on the other side of the equal sign. My x is positive. All right, so that's how you move things around. Let's take a look at how we use these for each of the standard forms. So remember what I was saying early on. Standard form allows us to determine the x and the y intercepts. So when x is 0, this means it's where the line is going to cross the x-axis. So x is, when x is 0, oh, I got it backwards. When x is 0, when x is 0, what is y? So this is the y-intercept. Okay, so when I make x 0, that's going to tell me my y-intercept. Because look, it says y equals 4. That's very clear. So when x is 0, y is 4. Now, I'm going to do the opposite thing. I'm going to make y 0 down here. When y equals 0, that takes out that part of the equation. So I get 4x equals 8. If I divide both of these by 4, okay, those cancel out. X is going to be 2. So this is my x is 2, y is 0. This is my x-intercept. So this one is going to sit right like that. Boom. There, if I can connect them. There's my line. So standard form is a really quick way to pinpoint those two main points to draw your line. I actually prefer it than the other way. Here's another one. Let's take a look at this one. I got 3x minus 4y. So again, I want to find out what my y-intercept is. So I'm solving for y. I'm going to make x 0, right? So I get 0. So when x is 0, I get negative 4y equals 12. So here, I'm going to divide by negative 4 on both sides. Y is going to equal negative 3. So that's my y-intercept. That's where it crosses the y. Y equals negative 3. When I do that for the x, I make y 0. It takes that whole term out. I get 3x equals 12. Divide by 3. X is going to equal 4. So I have these 2 points. What I've done here is I've actually plotted the first one. Set this over here. So in this term here, I have 0, comma 4. So I go to 0 and I go up 4. There's my y-intercept. My x-intercept was 2, comma 0. So this one line represents the equation 4x plus 2y equals 8. Okay, now let's plot the next one. So I get 0, negative 3. There's my first point. And my x-intercept is 4, comma 0. 4, comma 0. What do we do next? Not too hard. Connect them with a ruler. So what they primarily teach is that there are 2 ways to solve systems of equation, when in fact there's actually 3. You can actually go in and plot this manually. So what is this point? I can only get an estimate here because it doesn't hit equally. So my x is about, it's about 2.5. My y is about negative, I'd say it's about negative 1 point, or 1 and 1/10, somewhere around there. Okay, so what this does though, it gives me a ballpark. Right? So this is what we're actually doing in the systems of equation. When we add the two together, we're finding the exact point where they meet. Right there. A really important thing when you're doing things like graphing, when you're doing Cartesian plane work, when you're dealing with boats and planes, you don't want them to hit, or maybe you do want them to intersect. When you're navigating, these kind of calculations come into play. So I want you to have a visual. Now, sometimes, so this, when we add these up, this is going to be like x equals 4. We're going to get an answer to it. If we get something, oh, I have it over here. Look at me, all organized. So when I get an answer where x equals 4 or y equals 3, that's telling me I have an independent system of equation. That means they meet at exactly 1 point. Now we can do this with 3 expressions, with 4 expressions. It just gets more complicated. Sometimes you're going to end up with this, 0 equals 4. So why would that happen? This would happen if we have equations like this. 3x plus 2y equals 7. And down here I get negative 3x plus negative 2y equals 9. So what do we hear? When we add these, those cancel out, those cancel out. I'm left with negative 2. So here I have 0 equals negative 2. What this means is that I have 2 parallel lines, and the distance between them is going to be 2. But they don't cross. If I have an x and y coordinate, that would mean they cross. Good, I'm still recording. Just a sec here. Option P. I'm back. Sorry, I had to I had to check something out there. Uh, Camera zoom. Wait for it. There we go. Now, the last situation here, so that's called an inconsistent. Sometimes I just have to, there we go. Inconsistent means that they are parallel lines. It means that I'm getting a strange answer. Now, the last one you're going to get is this, and this is called the dependent systems of equation, where I get 0 equals 0. So in this example we have up here, if that was 9, and this is 9, or negative 9, what this means is that this is the identical line. So it's also going to come in when we have things like, what is it called? The brain stopped working. 2x plus 2y equals 2. And then here I get negative 4x minus 4y equals negative 4. Equivalent. So these are equivalent. If I multiplied the top one by 2, then these would completely cancel out. I would get 0 equals 0, same line. So 3 different choices. If I have a solution, it's independent, meaning it crosses once. 2, inconsistent, which means that they will not cross. They're going in the same direction. Number 3, dependent. Dependent meaning that they are the identical line, but they are equivalents of each other. Okay? All right, let's get to work. So the first way that you can determine to get a good idea of where things are at is by graphing it. Okay? So when we get to here, you're going to hear these terms a lot. There's elimination and then there's substitution. In both of them, we can make equivalent equations. So remember, an equivalent equation is just when I take an equation. Let's just do one here. I take an equation, 3x minus 2y equals 3. Okay, now I could plot this, but I'm not going to. If I multiplied this entire thing by, let's say 2, negative 2, we'll make it easy. Multiply it by negative 2. Every term within that equation, I have to multiply by negative 2. So I get negative 2 times 3x gives me negative 6x. Negative 2 times negative 2y gives me positive 4y. This is going to give me at the end negative 6. So these two are the same equation, equivalents. Okay? In both of these things, elimination and substitution, we're going to be using equivalent, what are they called? Equivalent equations in order to allow us to either eliminate one of the variables or to substitute in. Let's just keep working on this one. Elimination. So let's take, I have positive 6x minus 6y equals positive 10. So remember, keep in mind here that these are just two different lines on a graph. Should we graph them? Should we map them out real quick? Let's do it. So I'm going to find these coordinates here. So if I take out the x, I get 4y equals negative 6. So if I divide by 4, it's going to be about, my y is going to be about 1.5. So about there. My x is going to be 1. Oh, negative 1. No, because a negative divided by, that's a negative. So this one's going to go like this. This one here, I get positive 6x. We take that out. I get negative 6 divided by negative 6. 10 divided by negative 6. Well, that's going to be negative, just under negative 1. And over here, I get 10x when y is 0. 10 divided by 6 is going to be positive. It's going to be like this. So it should look something like that. Now I've got a frame of reference. Sorry, a UPS truck just came. So remember, we're always adding these equations together because that's going to tell us where they meet. So in this situation, because I formed an equivalent ratio, negative 6, negative 6x and positive 6x, well, these are going to cancel out. This is going to give me 0. So here I have eliminated the x's. Here I get 4y plus negative 6y. That's going to be negative 2y. And I get negative 6 plus positive 10. That gives me positive 4. Now it's just a matter of straight algebra. I'm going to divide this side by 2, this side by 2. Y is going to equal negative 2. Okay, so already I know I have an independent solution. So I have a solution. Okay, now sometimes there's more than one solution. I'm going to leave that for next year. So now that we have this one solution, what we do is we insert it back in to our original problem. So I have 3x minus 2. My y is negative 2. So I'm going to put that in, equals 3. I get 3x minus, well, 4, negative 2 times negative 2 is going to be positive 4 equals 3. So now I'm down to algebra. So I'm going to move this over, minus 4. 3x equals negative 1, and I'm going to divide by 3, divide by 3. X equals negative 1 over 3. Okay, and if we look up here, my lines weren't quite clean enough here. Bet you that's more like that. Y is negative 2, so this would be down here. Yeah, maybe, maybe not. If you want to double check it, what we do is we insert this back into the other equation, and then we can solve for sure. Okay, so that's elimination. We have to have equivalent equations until we can completely eliminate one of the variables. And then we take that answer we get. We always have to do this second stage. We always have to do stage 2 to find out what the x is. Okay? Substitution. This one's a little more straightforward. But again, we have to use equivalent ratios to do it. So in this one, let's just do the same one. 3x minus 2y equals negative 3, positive 3. And then I get 6x minus 6y equals positive 10. Okay, so in this one, I'm going to make this 12. I'll show you why in a moment. Okay, so in this one, we are doing something a little different, because what we're going to solve for here is we're going to solve for one of the variables. And the reason I wanted to change this to 12 is that otherwise substitution doesn't work. Do you see how if I factor out a 6? So I can divide this whole thing by 6. So if I do that, I'm going to divide this by 6. Divide by 6. This is going to give me x minus y equals 2. This works really well because 12 is also a factor of 6. So when I have this situation, right, I can now actually solve for one of these substitutions. So what is y? Y is going to, what the heck? Yes, we go y equals 2 y. Let's solve for x. Sorry. So I'm going to solve for x. X is going to be 2 plus y. Okay? Sorry about that. I've been shooting a lot of video. So x equals 2 plus y. So stay with me here. So now we've figured out in this equation what x equals. So now what we're going to do is we're going to take this answer and we're going to plug it back in for x in our first equation. So our equation reads 3x minus 2y equals positive 3. I'm going to take 3 and now I'm going to insert this answer that we found. So it's 2 plus y minus 2y equals positive 3. Lots of delivery trucks today. All right, so this is a brilliant thing because see, now I have them down to one variable. I can only solve for one variable at a time. That's why this system works. So we have to distribute. 3 times 2 is 6. 3 times y is positive 3y. Minus 2y equals positive 3. Look familiar? Hope so. Now we have constants and coefficients. So next step, we collect like terms. So we get 6 plus y equals positive 3. I get rid of the 6, so I get y equals 3 minus 6. So y is going to equal negative 3. Okay, now do you see how many steps we have? I've just solved for y. All of that to solve for y, just like we did. Just like we did over here. First thing we have to do is find the answer to one of the y's. So here, y is negative 3. Next step. The step I find takes longer. It's my least favorite one to do, but sometimes it works. So y equals negative 3. Let's go back to our original equation. So we have 3x minus 2y equals positive 3. 3x minus 2y equals positive 3. Now I know what y is. See why so many students in high school hate this unit? So I get 3x minus 2 times negative 3 equals positive 3. So we're just taking the answers that we find, substituting them in for the variable. 3x equals positive 6. So I get 3x plus 6 equals 3. 3x minus 6, change side, change operation, equals minus 3. X equals 1. How'd I get that? Divide by 3, divide by 3. Ah, there's the error. Negative 1. So now I have these two numbers. Y equals negative 3. X equals negative 1. We still got to make sure it works. So here we go. We go 3 times negative 1 minus 2 times, what's my y? Negative 3. 3 minus times negative 1 is negative 3. A negative and a negative. So this is negative 2 and negative 3, which is going to give me positive 6. Negative 3 plus 6 gives me positive 3. There's our original. So what that does is that confirms that these two lines are going to cross at x of negative 1, y, sorry, x negative 1, y negative 3. Whew, see, a lot of work. The only time that substitution really becomes valid is if they just give you something already. That's pretty much the only time I use it. If I can quickly jump between the two and eliminate one, rearrange this formula so I have a single variable, that's when I use it. There's this one other thing I want to show you. This is the higher level as it gets harder. So here we have fractional coefficients. Fractional coefficients, they'll give you multiple of them. So this one would be like 1/2 x minus 3 over 7y equals 1 over 4. You have to do the same work, but we can get rid of these things really quickly. So remember, if I multiply the expression, I have to multiply each term within that expression by that number. So when we look at this, it's back to fractions. 4 and 2 are both constants, or they're both they're factors, right? So if I multiply this by 4, let's see what we get. Okay, so what we get is we get 4 times 3 over 4x. Well, these 4's are going to cancel out. Then I get 4 times 7 over 2y. These simplify down, right? So this just becomes a 2. That 2 gets canceled out. And this is going to equal 4 times 10. So what we end up with is 3x plus 14y equals 40. Like that. So don't let those fractions throw you off. The key is you have to find a common, like a common denominator that you can multiply them all by. This one here, what do we got? We got 4, 2, and 7. My first instinct is 14. That's not going to work. So we're actually going to multiply this one by 28. Right? So 28, now these numbers are going to get big, but at least we're not dealing with fractions. I hope that helps. It's complicated, it's challenging. Let me know if you need help. Try the worksheets. Again, this is just going to help you next year when you see this unit. So any kind of concept you can get now will make it much easier. Two main ways: elimination, where you're making equivalents so you can cancel out one of the variables, or substitution, where we use an equivalent equation to rewrite so we can have a single x or a single y on one side, and then we can insert that back in. Thank you so much. Good luck.